This image may be familiar to you. It's an artist's conception of how our home galaxy, the Milky Way, would look if we were outside it. But does its very existence present a cosmic puzzle? Spiral galaxies like our own are torn up and destroyed when galaxies merge. These mergers are common in the universe. All galaxies experience them. So why do we see spirals at all? Why does the Milky Way still exist in its familiar form?
One possibility is that when sufficient gas is present in a merger, it can condense to form new young stars that form a spiral disk around the spheroidal remnant that was left behind. This spiral disk regrowth process is predicted in theoretical models of galaxy formation, and a hint of it can be seen in this simulation as the blue points, which are the gas, swirl around the stars in the middle.
To look for observational evidence of such galaxy rebirth, we made use of the GALEX space telescope's ability to image in the ultraviolet region of the spectrum, where we see hot, young stars like those forming in the Milky Way's own Orion Nebula. GALEX has already unveiled previously undiscovered disks shining brightly in the ultraviolet, which represent new stars forming in the outer regions of living spiral galaxies.
Just recently, GALEX has found that some supposedly dead spheroidal galaxies actually show new disk growth in the form of previously undiscovered ultraviolet bright disks. You might wonder, is this the rebirth that was predicted? If so, it could be exciting, because this could solve the puzzle of spiral galaxy destruction. Exploring this idea further, we started a study to see how common these ultraviolet bright disks are in these supposedly dead spheroidal galaxies.
In the end, our data showed that ultraviolet disks are actually more common around dead spheroidal galaxies than living spiral galaxies, which was a bit of a surprise.
It's possible that living galaxies have been forming stars long enough that many cooler, optically visible stars have filled in the disks in their outer regions, whereas the supposedly dead spheroidal galaxies are just starting to grow a new disk with the hot stars we detect in the ultraviolet.
But is this ultraviolet disk regrowth substantial enough to create lots of new spiral galaxies? That's where the next phase of the research is headed, as we try to solve the puzzle of how spirals can be so common despite undergoing frequent mergers.
Solving this puzzle is an important element of understanding our Milky Way's life story. It's entirely possible that our home galaxy rose from the ashes of a violent collision to form the beautiful, familiar spiral disk that we inhabit today.